Okay, so this process becomes cumulative. It is just like you are expecting an avalanche breakdown. So in avalanche breakdown, the current becomes enormous, right? So the electrons will start hitting other electrons, and this becomes a cumulative process. So the current ratings will increase. So in transistor, you have what is called as maximum rated collector current. So that is the maximum collector current your transistor can withstand. So if the current is going to exceed beyond that maximum rated collector current, transistor may self-destroy itself. So the transistor will be burnt, and you have to throw the transistor and you have to use a new transistor. Okay, so you should ensure that at any cost, the collector current is not going beyond the maximum rated collector current because of thermal runaway. This happens because of variation in temperature. Okay, that is why in the beginning when we studied about BJT in electron devices, we have seen that among the three layers, collector area will be very large, emitter area will be relatively smaller than collector, and base will have the least area. So the reason why collector is going to have a large area is when the area is large, the heat dissipation becomes faster. The heat can dissipate into the environment faster. the, your uh, your mom will know better about this when they are cooking. So when you cook food in a broad base vessel, the heat will be distributed uniformly. The same thing when you cook in a vessel whose diameter is very very short, it takes a lot of time to get cooked. Same concept here. So everything comes from nature, right? So when the area of collector is made larger, how much amount of heat is produced in the collector junction, that will be dissipated into the environment very faster. When the area of collector is going to be very very small, the heat dissipation becomes a problem which will eventually damage your transistor. To some extent, I can prevent the damage of the collector junction by making the area of collector larger. So this will lead to dissipating my heat quickly into the environment. Okay, or I can say, see, temperature increase you cannot avoid, and you cannot make the collector size also larger because your circuit will become bulky. Nobody needs a bulky circuit, right? I want a circuit which is very slim. So if the area is large, my circuit becomes bulky, it will not be handy. So what one thing we can do, if collector current is increasing because of temperature, we can have an alternate way where I can reduce my base current. So if I reduce my base current, accordingly, the collector current will also be reduced. So one side collector current is increasing, one side collector current is decreasing. So the effect is neutralized. Is this logically? That is explained in the third point. See here, if the circuit is designed in such a way that if I reduce my base current automatically when the temperature is increasing, then the collector current will also decrease. So on base side, collector current is decreasing. On collector side, collector current is increasing. Effectively, the variation is zero. So in that way, intelligently, I can ensure that the collector current is almost same. So if I am doing this way, my Q point is initially in the middle. Because of rise in temperature, Q point will slightly move up. But since I'm reducing my base current, the Q point will again move down and it will come to its original location. So the Q point location is not altered. Okay, so this is going to be the effect of thermal runaway in BJT. This issue is still there. Although there are many methods to prevent thermal runaway in BJT, but you cannot ignore the effect of thermal runaway in BJT. You cannot say BJTs are free from thermal runaway. No, I can minimize the effect of thermal runaway in BJTs using appropriate circuits. So one such, see, this is for a normal transistor. If you are using a power transistor means the output power will be in the order of watts. The output power will be in the order of watts. So if that is the case, enormous amount of heat will be produced in the collector junction, which have to be quickly removed. If the heat is getting accumulated in the collector junction, it will lead to permanent damage to your transistor. So what they will be using, they will be using an element called heat sink. The heat sink is a metallic sheet which is fitted to the collector of the transistor. This heat sink will absorb the heat from the collector immediately and dissipate or radiates into the atmosphere, so that the collector junction is always kept at a constant temperature. Okay, so this is the purpose of a heat sink, which is used in power transistors, which is specifically used for removing the heat produced in the collector junction, so that you can ensure that the collector junction is free from damage.